In today's class, you are going to learn how to compute the expected values of discrete random variables, their variance, standard deviations, and also we'll do some examples of your homework, but we are going to use Excel to make those computations. So I'm going to teach you how to do that manually and then also how to use Excel to achieve that. And then we're also going to look at the various properties of expectations and also variance. So we'll first start by understanding the definition of a random variable. So a random variable is a numerical value assigned to the outcome of a random experiment. For example, when you roll a six-sided die. So let's say we are going to use X to be the random variable, which is going to represent the outcome. So for example, when you roll a die, you could either get 1, 2, 3, 4, 5, or 6. And so X is a random variable. And you can see that it's representing the outcome of the experiment. What is the experiment here? Rolling of what? A die. Is that okay? Good. There are two types of random variables. We have the discrete random variable and then the continuous random variable. In chapter 14, we are just focusing on discrete random variable. We are going to learn how to compute the mean, variance, standard deviation of discrete random variables. So let's start with how do we compute the expectation or the expected value of a discrete random variable. So I will recommend that you write this formula in your sheet. This is the formula for the computation of the expected value of a discrete random variable. I recommend that you write this formula in your sheet. How do we implement this formula? We are going to look at an example. So this is the example. The example says that a coffee shop tracks sales and has observed the distribution in the following table. So this is the table. What is the average sales can it expect? So average, it means we are going to compute the expected value or the mean. So we are going to, now we can see that this is what? A discrete random variable. So to be able to compute the expected value, we are going to make use of what? This formula here. So to do that, I decided to rewrite this as in a different format. So you can see these are the sales. Sales is here. Same thing as in the problem with their probabilities. So when you scroll up, you can see it's the same thing. So sales and probabilities. I decided to write it this way. I wanted to write it in a column form instead of the row form, because when you write it in the column form, it is easier to work with. And so how do we find the expected value? This is a discrete situation, and so we know the expected value, which is mu, is equal to summation of x times the probability of x. I have told you to write that formula in your sheet, so it's this here. And so these are your x, and then these are your probabilities of x. So I decided to create a new column to make those computations. So when you look at the column I have created here, so x times the probability. This is the x times the probability. So 155 times 0.16 gives you 24.8. And you go to the next row, 160 times 0.22, 165 times 0.39, 170 times 0.17. So it was the same thing I did. And when I finished, the formula says this thing here means sum. When you finish, add all these. That is what the formula says. Do individual x times these probabilities, and when you finish, you add all of them. So when you add 24 plus 24.8 plus 35.2 and add everything up to 10.5, it means that what? The mean is what? 163.75. So this is how to compute the mean or the expectation or the average of a discrete random variable. You'd see that it is a discrete random variable. You'd see values and you also see the assigned probabilities. That is one thing to look out for. Good. Now, let's try to implement this in Excel. So for example, let's look at, so I want you to open chapter 14, homework question 1, so that we'll do it together. But this time around, we are going to implement the formula, but using Excel. So now you can do this manually, but let's try to also use Excel to do it. So this is my homework, chapter 14, question 1. We want to compute the average daily sales. You can do it manually, or you could also use Excel to do it. So let's see how we are going to use Excel to do it. So when you click on this thing here, it says, so I choose open in Excel. When you click on that, it downloads it for you, and then you just click to open. So I have it here. Remember, the formula says x times the probabilities. So I try to create a column here. I put x, and then I put p of x by it. Is that okay? I create a new column. So we want to multiply the number of sales by the probability. The number of sales is the x, and then the probabilities is the p of x. So to do that in Excel, I come here and then I hit equal to. And then I click on 130. I take the arrow there. When you click on that, it gives you A2. And then I hit multiplied by, and then I hit the probability. So you see it becomes equal to A2 times B2. Can you all see that? And then you hit enter. I'll do it again. So to do this in Excel, we are looking for the mean. You have to be able to know the formula for the mean. That is why I told you earlier on to write that formula in your sheet. Now, in your homework, it is easier to do it in Excel. So how do we do it in Excel? I create a new column and I label it X P of X. I just type this there. Is that okay? Now, what does XP of X means? XP of X means that number of sales times the probability. The X represents the number of sales. Is that okay? So to do that in Excel, now I take the cursor and I put it here. You see, it's there. Then you hit equal to. When you hit equal to, then now hit where the 130 is. When you hit where the 130 is, it's going to write A2, not 130. Can you see that? And then I hit this star, like the one you see it, it's closer to hit in on my MacBook, it's shift 8. On the keyboard 8, you see that sign there. It's like a star by its multiplication. Can you all see that? So when you do that, you after you do that, you come and hit B2 or hit this one. So you see how it works. So now it's equal to A2 times B2. Can you all see that? When you are done, hit enter. Does it give you a value? Okay. So just hit equal to on your keyboard. Mm-hmm. Mm-hmm. And I'm going to click on the where the 130 is. Mm-hmm. Oh, okay. And then look on your keyboard and hit times. Not this one. Oh, okay. Mm-hmm. And then hit this one. And then hit enter. Good. Okay, so when you do the first one, you don't need to do for all of them. So when you do the first one like this, look at me. I just bring my cursor here and I scroll it down. You see, then it gives you for all of them. Does that make sense? Do you see that? Okay. And then what does the mean say? The mean says that what? We should sum all of them. So to sum all of them, I just bring the cursor down and I say equal to. When you try to hit sum, Excel gives you sum. Do you see that? Let me do it again. I want to find the sum of all these. Is that okay? So to do that, I bring the cursor down to any of the rows below the table. Is that okay? So I just hit equal to, and I try to type sum as you see it gives you sum. Can you see that? And then you click on that. Okay, I'll do that again. Okay. So you were able to get this. You got this correct. So I take the cursor there. Now you see this thing here. Bring it to the bottom here. You see, do you see that? And then hold the cursor and then draw it down. Good. So to get the sum, I just hit equal to you see sum, not sum if, sum like that. And then you just go and select everything here and then hit enter. So it gives you 138.9. And then you can come and put that here. Any questions? You sure the sum again? Okay. So to do the sum, I just come to it. You could do it here. You could do it anywhere. You don't want to do it here. Is that okay? So I just do here. I put my cursor here. I hit equal to, and then I try to type SUM. SU. You see, Excel automatically give you steps, and then I hit on sum. Is that okay? And when you want to sum everything here. Not, it should include the P because that is not a number. Is that okay? So then you take your cursor to the first one and then you see, you drag it down. Do you see that? When you just do that, just hit enter. It's just going to give you that.
So what do these values mean? Like, is the sum of all of them the mean, you said?
So this value, this is not the sum. So this sum here is a sum of the number of sales times the probability.
Okay.
Just like what we did in the example in the slides. Any questions? So that is how to use the Excel to compute the mean of a discrete random variable. Now let's proceed.
So are we like doing the number of sales times the probability to find out the random variables?
No, the random variables is the sales and then it's
Oh,
assigned probability. So what we just did is trying to find the mean of the random variable, of the
okay.
discrete random variable.
So like those numbers on the right are the mean for each of those?
Not the mean for each of those. Those are the formula we are going to use to get the mean. So we are just trying to find the number of sales times the probability, number of sales times the probability. That's what on the left here. And to find the mean, we sum all of them.
Okay, so then the sum of all those is
Is
the
the
mean.
mean.
Okay,
Yeah.
okay, that's what I was wondering.
Okay. The next thing we want to compute is the variance. The variance, there is two formulas. I have written both of the formulas for you. Like I told you, in this chapter, we are just focusing on discrete random variables. So the variance of a discrete random variable is given by either this, or this. Is that okay? And just like we've learned previously, you see this is what? So to represent the variance, it's sigma squared. Is that okay? So when you say sigma squared, it is the variance or this. Now, I find the first one easy to implement. So that is what I'm going to focus on. But these two, they will give you the same thing. But I find the first one easy to implement. So that is what I'm going to work on. So what the first one is saying that we know how to get this. This is the mean squared. And we are going to do x squared times the probability. That is what we are going to do to get the variance of the discrete random variable. And also would also be asked to compute the standard deviation. So anytime you want to compute the standard deviation, first find the variance and then you find the square root of the variance. So you can see the standard deviation is the square root of the variance, which is the same thing here. So I will again recommend that you write these formulas in your sheet because when you have these formulas, implementing them is very easy. Is that okay? Any questions? So like I said, two formulas. I find the first one easy to implement. The second one too, you could also use that if you want. That is the variance. So variance is always sigma squared. And if you want to compute the standard deviation, it's always sigma. So look at the difference between them. You see variance has squared on top. Standard deviation has no squared. Is that okay? Good. And the standard deviation is the same as what? The square root of the variance. Now let's try to see how to implement this formula. So let's look at this example. We are told that a couple plans to have children and blah, blah, blah. And then this is the table, and we want to find the standard deviation. So to do that, I write the x, which is here. You see x is 1, 2, 3. I decide to write it here. Can you see that? And then there are corresponding probabilities. Probabilities for 1 is 0.48, 2 is 0.25, 3 is 0.27. It's the same thing here. Is that okay? Good. Now, what is the formula? This is the formula for the variance. The first thing I want to do first is to compute this guy, which we already know is what? Summation of what? X dot px. So you see, I decided to do that here. x times px. X is 1. 1 times 0.48 is 0.48. 2 times p of x. 2 times 0.25 is 0.5. 3 times 0.27, that way. Then you sum all of them. When you sum all of them, the total gives you 1.79. So you can see from here, our mean is what? 1.79. Is that okay? Even though I'm computing for the standard deviation, but the formula requires me to use the mean. That is why I computed that first. Can you see that? So it means that looking at this formula here, I have been able to sort this guy out. Can you see that? Now what we are left to compute is x squared times p of x. So I create a new column and I label that x squared. This is our x. And we want x squared. So 1 squared gives you 1, 2 squared gives you 4, 3 squared gives you 9. Is that okay? That is my x squared. And then the formula says x squared times p of x. So you see, x squared times p of x. X squared here is 1. 1 times p of x. P of x is 0.48. 4 times 0.25. 9 times 0.27. So you see, when you do that and then you add all of them, you get this. And then now we want to implement the formula. The formula says you sum all of this, which is this one here. It is 3.91 minus the mean squared. You see, this is the mean. And then I square that. And then you can use your calculator. You get what? 0.7059. This is the variance. We also want to compute the standard deviation. The standard deviation is just the square root of the variance. So you see, standard deviation is what? Square root of the variance, which is this. That is how to do that in manually. So like I said, it's very important that you write out the formula. Now, how do we implement this in Excel? Let's go and try your homework question number 9. Let's go to question 9. There we go. So they want us to find the standard deviation of the random variable. So you see, we come here and then we open in Excel. So you see, when you open in Excel, you have this here. Then you just have to look at the formula you have written down. We first need the mean. How do we go about that? The first one is what? We want x multiplying p of x. That is what we want. The first thing we want is, anytime we want to compute the standard deviation or the variance, we are going to utilize the mean. So you see, I create a column for that. Now we do the first thing we did. We just come here and say equals x times p of x, this times that. You see how it worked? And then we just scroll, we just hold this one and then bring it down. Do we see that? Can you see that? Okay. When we do that, we want the sum. So let me try to write here. Let's do sum here. Or let me put total here. Total. So now we want to add all these. So we put equal to sum. Excel gives you. You have to make sure you use the Excel one. It's capital SUM. And then we just bring all these three and hit enter. Is that okay? We have been able to compute the mean. How do we compute the other one? The next thing we need is x squared. So we come here, I create x, I just do this, x squared. Is that okay? You are labeling the various columns. Is that okay? So you have you have the opportunity to write the formulas down. Write the formulas down. Your responsibility is writing the formulas down properly and implementing them properly. So I do x squared. So for me to get that, you come here and do equal to, can you see that? And then we come to x here, and then we hit this and say squared. And then you hit enter. Do you see that? How did I do it? I create a new column and say x squared. Is that okay? Where is x? This is x. Is that okay? I want the square of them. So I come here and I say equal to, and I hit this one, 1. You see? Take your cursor there. It still gives you a2. Is that okay? What do you want? You want the square. Go to, look on your keyboard. You see, hit shift 6. It gives you that thing. Do you see that? And then just put in 2 here. Is that okay? It's very important that you try them, because when you have this in your exams, you'd have to be able to figure it out. Is that okay? And then you hit enter. When the first one is okay, all you need to do is to drag it down. You see, then you can compare. 2 squared is 4, 3 squared is 9. Can you see that? Now, what do we need? We need x squared times p of x according to the formula. So you see, I put x squared multiplied by p of x here. I create another column. Do you see? Create another column and do x p of x. I'm not able to zoom it bigger. So I don't know. But so x squared p of x. So where is my x squared? My x squared is here. Is that okay? So now to come here, I do equal to, where is my x squared? My x squared is here. I click on this one here. Can you see? So it gives you d2. And then times p of x. Look at where p of x, not x p of x. Look at where p of x is. Is that okay? P of x is b2. So you see, my x squared is here. My p of x is here. I need x squared times p of x. Can you see that? And then I hit enter. Okay, I'll do that again. Were you able to get x squared times p of x, the heading? Okay. I just do equal to x squared multiply p of x. X squared is here. Is that okay? So I just click on that. And then you look on your keyboard, you'd see the star thing on 8. So you hit shift 8. It gives you the star. And then we are looking for p of x. Be very careful, not x p of x. It's s squared multiplied p of x. This is p of x. Is that okay? It's on the B row, B column. So I click on that. Can you see? So it's like D2 times B2 based on mine. When you do that, just hit enter. Can you see that? When you finish, when you check it's correct, all you have to do is just to drag. And now drag it. Is that okay? Then we want the total of that too. So we come here, just do equals SUM. And then you just roll all of them, hit enter. Is that okay? And then now you can implement. So I could come here and say, okay, variance is, it is this minus the mean squared. Can you see that? That's what the variance formula says. It is this minus the mean squared. You just hit on that, you get this. And then if you want standard deviation is going to be SD is the square root of the variance equals, you do S, type SQRT, you see, SQRT, and then hit on this one here, then hit enter. So it's 0.85075.
How did you get the part with the variance? Mine just came out like differently.
Okay, so to get the variance, you have to be able to look at the formula we wrote. We wrote the sum of this minus the mean squared. This is the sum here. Is that okay? So I just do equals the sum of this one here minus the mean squared. This is the mean. Is that okay?
Oh, okay, that's what I did wrong. I did
Minus the mean squared. Does that make sense? And then just hit enter.
No, I got it.
Yeah.
How did you get the standard deviation?
So to get the standard deviation is the square root of the variance.
Okay.
Even when you use the Excel to get this, you can use your calculator to just do that. Is that okay? But usually I prefer to use Excel for everything. So as the standard deviation is square root of the variance, I just do equal to, just type SQRT. You see, Excel gives you. You just do the SQRT of what the variance, this value, you see, and then I click it and it gives you it. I just hit enter.
Okay.
That's all. So I got 0.85075. And then you can come and put that here. So that is how to do it. Now let's proceed.
Giving me like an error.
Okay, I'll come there and then try to help you out. Okay, now let's proceed. So now we know how to compute both the mean standard deviation variance of discrete random variables. This is manually and also using Excel. So when you go home and then you are confused on using the Excel, I'll upload the video lecture of this class. You can also follow. So that is also okay too.
Can you? So for the, is there a different, like for the top of that chart,
Mhm.
can we use that as a formula for Excel? Instead of just using the formula down there, can we also put X times B of X?
Yeah, yeah. The is your homework problems and exams. They are multiple choice. So even if I'm the one doing the exam, I won't even label the top, so I could go fast. You just have to know what you're doing. Does that make sense? Because I'm not grading your steps. The Pearson grades your final answer. Is that okay? So however you are going to do it in Excel, just make sure you are doing the right thing. Does that make sense? Yeah. And then let's proceed. Now, we've done this already, but we are going to refresh our minds on them. What happens to the expected value when we add or subtract a constant? We've done shifting and scaling already, but we are going to do this for random variables too. So whenever we add a constant or subtract a constant to the random variable, the expectation becomes this. I recommend that you write this whole thing in your sheet. It's very important. Is that okay? Write this in your sheet. So you see, for the expected value, when you add a constant, it says the expected value of the random variable plus the constant. Is that okay? So for example, if we subtract a constant, the expected value of the random variable minus the constant. But as for the variance, when we add a constant, the variance doesn't change. You see, the variance is always the same. Is that okay? Let's look at example. So we see here, we are giving, in this example here, we are giving e of x to be 20. And whenever you see this is the variance. We've talked about it already here, that this is the variance. So you can see it means var of x is equal to 100. Is that okay? We want to compute the mean of this. How do we compute the mean of that? So we want to compute the mean of what? X plus 7. So this one looks like this. X is the random variable. This 7 here is the constant. Is that okay? And based on this, it is the same thing as what? E of x plus 7. Is that okay? Now we proceed. What is E of x? 20 plus 7. So you see, we get 27. Does that make sense? Now, we also want to find the variance of that. How do we go about it? Variance of x plus 7 is equal to, now you can see that that looks like this thing here. It looks like this one. Is that okay? 7 is a constant. We say that whenever we add or subtract a constant from the random variable, we are finding the variance doesn't change. So this is the same thing as what? Var of x. That is why I told you I recommend you write this in your sheet. That way you can just look at it and then you can look at what it's corresponding to, and then you can write that. So var of x, we know the var of x here is 100. You see, it didn't change. So that is what I wrote here. Is that okay? Good. Any questions? Let's get to the other one. Now, write these two in your sheet. Now here we are multiplying the random variable by a constant. When we multiply the random variable by a constant, this is what happens to the mean. We multiply the mean by that same constant, but we multiply the variance by the square of the constant. Is that okay? We multiply the variance by the square of the constant. So now let's look at this example here. So when we look at this example, same thing. Whenever you see this, okay, take your time and say this means variance. So from when I look at this, I see E of x, which is the mean, is 20. This is variance. So I write variance to be what? 100. Is that okay? and I want the mean of 3 of x. The question is this. The question says that find the mean and variances. So mean, expected value of what? 3 of x. So you can see here 3 is the a. Anytime we have this is the same as a e of x. So this is the same as 3 e of x. Is that okay? Now, what is 3 times e of x? What is e of x? 20. So you see your answer is what? 60. Is that okay? Now let's find the variance. Variance of 3 of x. Anytime we are multiplying by a constant, for the variance, it comes out what? Squared. So this is going to be what? 3 squared times the variance of x, which is going to be 9 times, what is the variance of x? 100, which is going to be what? 900. So you see, that is what I wrote here. So it's very important that you also have these properties down. So now we have talked about adding a constant and also multiplying, adding or subtracting a constant or multiplying. So just know what happens to the mean, know what happens to the variance. If you want the standard deviation, first take your time, do the variance, and then we can find the square root of the answer to give the standard deviation. And also, whenever you have two random variables, say x and y, the expectation of the sum of two random variables is the expectation of the what? Individual random variables. So this is the expectation of x plus expectation of y. So write this down too. And then the variance too is the same thing for two independent random variables. When we are adding x plus y, it is this. Even if here is negative, it's always positive. So just know that. Does that make sense? Write these two down in your sheet. Even if here is negative, when we are summing two of them, it's positive. But for the expectation, if, for example, if you have e of what? X minus y, it's going to be e of x minus e of y. But for the variant, it's going to be what? Positive. And then this is also one last thing. Whenever we have a sum of independent random variables, we can sum the individual means, which is given as this, the individual variances. Now let's try to do this problem. This is question 13 from chapter 4 homework. We will do this step by step. So they want us to find the mean and the standard deviation of each of this. So this is part A. So whenever we have this, let's take our time and write. Look at how I'm going to solve it. So the first one, what is e of x? Now tell me, what is e of x? Look at the table and tell me, what is e of x? What is the mean of x? 70. Do you agree the mean of x is 70? Okay. What is the variance of x? You were given a standard deviation. How do you get the variance? You square the standard deviation. Is that okay? So the variance is going to be what? 12 squared, which is 144, because you were given the standard deviation, not the variance. Is that okay? Okay. Now let's write, what is the mean of y? 16. What is the variance of y? 9. So variance of y is, this SD is the standard deviation, so it means 3 squared is 9. Now let's come here. Let's do the mean. Let me divide this into 2. Let's do the mean of 2y plus 10. Is that okay? So the mean of 2y plus 10, based on the things we have learned here, and this, and that, it means that the mean of 2y plus 10 is going to give you 2 mean of y plus 10. Can you see that? So this is going to give you 2 times, what is the mean of y? 16 plus 10. What is 2 times 16? 32 plus 10, 42. Now let's do the variance. Variance of 2y plus 10 is going to give you, now this is a constant. We know that when we add or subtract a constant, it doesn't change the variance. So this is going to give you 2 squared variance of y. What is 2 squared? 4 times variance of y. What is variance of y? 9. It's 36. The question doesn't want you to find the variance. The question wants you to find the standard deviation. And so standard deviation is equal to square root of the variance square root of 36 equals 6. So I'll end here and I'll continue the example on Friday.